The topic that we will be discussing today is about electricity, and we know how important electricity in our daily lives. And then, as a future electrical engineers, this is so important to know what electricity, what basic concepts that this topic is to be discussed. So now, the learning outcomes for this topic, you will be able to develop and use a conceptual model of a simple DC circuits, understand the concept of basic electrical quantities such as power, voltage, current, energy, and etc. And then you're going also to understand series and parallel circuits and as well as its combination. Draw and interpret basic circuit diagrams. And then lastly is to understand the physical basic for Ohm's law and Kirchhoff's law and use these laws to analyze circuits. Now, uh, for our first lesson is we are going to discuss the basic electrical quantities, and we know that we have a numerous electrical quantities in our major subjects. So the first one is about electrical charge, and we know that it is carried by the electrons and protons within an atom. And then electrons are said to carry negative charge, while the protons are carry positive charge, and then neutrons is the neutral. The SI unit of electrical charge is coulombed, and take note that one electron or one proton has a charge of 1.6 times 10 raised to negative 19 coulomb. And then next is about electrical current, and we know that the rate of electrical current or electron flow in a given material, so its SI unit is ampere. So the formula would be current will be equal to electrical charge divided by time. So the current is designated by I, the charge is Q, and the time is T. So take note for the SI unit here. Okay. So now let's discuss the electromotive force or the EMF or the voltage. We know that the voltage is the energy produced by a cell or battery or a generator per coulomb of charge passing through it. That is, a unit of EMF is joule per coulomb, or commonly called volt. So now let's discuss the basic concept of volt and ampere, or how does an electricity form. Okay, so we say that we have a conductor or a wire here, and we know that volt is a force, or it measures the electrical pressure, and then ampere is the current. It is the one that flows in the wire. So the concept here is that we have a wire and we have a power source or our power supply. So we know that for every conductor we have electrons. Okay, so the one that is flowing, that is the free electrons. Okay, as the volt or as the wire is being energized by the power supply, so the electrons will flow, right? Or since this is the force, it will pushes forward, or the electrons will flow, and that is the time when we say that since the electron is flowing, and the flowing of electrons, or the number of moving electrons or electric charges, that is what we call the ampere. That is the current now. Okay, so next so take note again that we designated the voltage or our electromotive force as E, and then our energy consumed by a particular load is W, and then the electrical charge is Q. Okay, so Next is the electrical resistance. The electrical resistance. So we know that the electrical resistance, it is an electrical quantity that opposes or that resists the flow of electrons. So we need the resistance in order for a particular circuit not to be over current or overloaded. So we need an electrical resistant loads. There is a unit of electrical resistance is ohm. Okay, we know we have here the formula equation for an electrical resistance. So R is equals to rho times L divided by A. So resistance of a conductor or material is directly proportional to the length of a conductor and inversely proportional to the area of a conductor. So at this point we could say here in the equation that the greater the resistance, the greater the length, the greater the length of a conductor, the greater the resistance. The smaller the area of a particular conductor, the greater the resistance. The bigger the area of a particular conductor, the smaller the resistance. So here, R is designated as for our electrical quantity, resistance measured in ohms, and then the rho is the symbol for resistivity. The unit is ohm meter. L is for the length in meter, of course, and then the area or the cross-sectional area is in meter, in meter raised to 2 or square meter here. Okay, at 20 degrees Celsius, the resistivity of anode copper wire is 10.37 ohm cm per foot, or 1.72 times 10 raised to negative 8 ohm meter. So kindly search the other resistivity like gold. So we have other kinds of metals. Okay, so note that, so it is a great reminder that if in a problem, let's say the conductor is not specified, we should assume that it is an anode copper and at 20 degrees condition. Okay, so our first example. For our first example in this module, we have a problem here. If a current of 2 amperes flows through a point in a wire for 30 seconds, how many columns pass through the point in the wire? So, as one of the effective way in solving a particular problem, so in math, in physics, is the first thing that you're going to do is to know the given in the problems. And next step is to know what is required or what is asked in the problem. And the next step is to formulate the formula, or you're going to put or to state what is the formula that you're going to use for the problem that is being asked. So here we know that as the problem itself says that we have a current, 2 ampere is our current, or this is 2 ampere or 2 coulomb per second. Take note that ampere is equal to coulomb per second. Do not forget that. So we have also here 30 seconds. This is our time. Time is 30 seconds. So how many coulombs pass through the point in the wire? And we know that coulomb, this is a unit for the electrical charge. So we could say that what is required or what is asked is the coulomb or the electrical charge. So this is just a simple direct substitution. We're going to, so next step is, so first you cannot solve if you don't have the formula for it. So we're going to Q. We know that electrical charge is equal to current times time. Thus 2 coulomb per second or 2 amperes divided sorry, 2 coulomb per second times 30 seconds. So just multiply. So just omit this one. This is, there's just a typo error. So 30 times 2 is 60. So canceling second, that is why we have 60 coulomb. So this will be our answer. So next step. So what quantity for our problem number 2? What quantity of electrical charge must be delivered by a battery with a potential difference of 100 volts to do 500 joule of work? Okay, so we know that in this example, first we're going to plot what would be the given. The 100 volts here, we know that this is already our potential difference or the electromagnetic force. Okay, then the 500 joule is our work, the energy consumed by the battery. Okay, so what is asked here is, again, is the charge, since the charge or what will be the charge. So to solve, just input or write the formula. We know that Q is equal, or the electrical charge is equal to energy consumed or the work done divided by the electromotive force or our voltage. So thus 500, which is our work, divided by 100. So we have 5 columns, and this will be our answer. So next example is, we are going to calculate. For our example number 3, we have here, calculate the resistance of a copper wire with 2 meters length and 4 millimeter diameter. So first thing to do is, again, we are going to state the given the problems, and we know that the 4 millimeter here is the diameter, or if we're going to divide it by 2, we can have our radius 2 millimeter, and then the length here is 2 meters. So what is asked or what is required in this topic is the resistance. So if we're going to solve this problem, so using our equation number 3 that was discussed a while ago, by inspection we have already the length, right? So again, let us recall the formula for the resistance for our equation number 3. We know that the resistance is equal to the length times the row divided by the cross-sectional area. So by inspection, this is not I mean this is given because it is stated here that we have a copper wire, and we can already have the value for our resistivity. The length is also given. We have 2 meters. Area is not yet given, but we can easily solve this one by using the formula 2 pi r squared. So first thing to do is we are going to our next to do is we are going to solve the area 2 pi r squared. So 2 pi times 2 times 10 raised to negative 3 raised to 2, our answer will be 2.5132 times 10 raised to negative 5. Okay, next step is just search again or recall the resistivity of all the metals that are widely used in the conductors in our field or in sa yung mga copper wire. So based in Google, the resistivity of the copper wire is 1.72 times 10 raised to negative 8 ohm meter. Okay, so last step is to solve for the resistance using this equation, and we have our resistance is 2 times 1.72 times 10 raised to negative 8. This is the resistivity, the length, divided by the cross-sectional area, which is 2.5132 times 10 raised to negative 5. So using your calculator, we could say that our answer is 1.3687 times 10 raised to negative 3. Unit is in ohms, and this should be our answer. So just try to solve this one in your respective houses. So we have 3 problems, so I know that this is just easy